Years ago, I had a television set. I think we got rid of the television in 2020. Well, it's 2020. We got rid of television in 2001, 2001, something like that, 20 years ago. And there used to be a television program, This Is Your Life. And some geezer used to come on, the presenter, with a big red book and say, "This, Fred Bloggs, is your life." Well, any red binder in our establishment is the files for a walkie-talkie. And this is the Midland file. See, that's when there were Dymo labelers before the electronic ones. And we've got the information on the 75720 and the 77810 Ready Rescue in this file, because it says so. And we did that DNT 3-channel handheld, so I managed to find with a belt loop and everything, my Midland 3-channel handheld. And when it says 2 watts on it, it really is 2 watts, because it says so. Then you've got to somehow get it out of its nappy. It's one I bought off eBay at some time, and it looks in nice condition. I've never looked at it. So just like with the DNT, we have 8 AA battery holder. The socket, I've already looked at the instruction book. The socket, if you don't have any batteries in it, becomes external power input, which is useful. So we still don't have an external aerial, so we can't do an on-the-air test, but we can do a range test with it, a field test with Mr. Chippy, etc. The 3 channels fitted, 14, 19 and 40, just to make things more interesting. And on this one you get a TX light. So, what did we think of it? There's our original. What did we think of it? We tested it last time in August 1984. It wasn't this set. It was a different set. Let's have a look. 001497. The serial number on this is 1351. I have on file a copy of the instruction book, because I had the sense to photocopy them at the time. Now I think this one came with the original instruction book, and I scanned that at the time, and we've now got a better copy of that. So we'll put my file away and we'll pause the video and we'll get out my new scan of that. Right, so we'll see what happens when we take the screws out. I've not been in one of these since 1984 when I took those photos for the file. We didn't service those at the time. They were always tested as they came out of the box. The difference with this is the metal case, and this is going to therefore have better range. Just tell you which. The crystals are not soldered in, they're plugged in, so you can change the channels if you spend £60 per channel having crystals made. But it does mean that if you want one on 10 metres, you can spend 60 quid and do that. And for people who think that's daft, well, you know, the hobby's very wide, and some people like to spend what you'd think was a ridiculous amount of money on some elderly products. So there's more to this than that DNT. Changes glasses. So this is a blown up version. And 14, 19 and 30 and 40. I think we'll do the test on Oh dear, it's a hard decision this. I think we'll tune it for channel 14, to be honest, and we'll do a test on there again. So it says we've got 2 watts. It says we're likely to get 1.8 microvolts out of it. Oh no, for 0.8 for 10 dB. So that's what you expect. I expect it's single conversion, but we'll just look at the circuit and a wiring diagram for when some little muppets pulled all the wires off to turn it into something else. So being a first generation scan, this is better than most of the other manuals and things. And isn't it wonderful that they did this? Things made by Maxon at that time, they always included a circuit diagram and a layout and sometimes a tuning procedure. It doesn't have any microchips in it, so it's probably a mid-70s design, and it would have been available in Europe, you know, like Germany and that. And then when UKCB happened in November 1981, they'll have pulled this old design and once again used it successfully. These were $49.99 new, like the DNTs were, and when Plustronics went bust, Dixon's bought the redundant stock, and I recall they were selling these at $12.99. Absolutely incredible. Should have bought bucket loads of them, but you never know, do you? So we're going to have to look at that circuit to find our way around this. We've got a 2SC2078 output transistor, so we know the PA is capable of 4 watts, which means that if it's doing 2 watts, having a telescopic error isn't going to be a perfect SWR, so it's a pretty bulletproof PA. Looking at 2 filters, 455S and then 455HT. Again, being a cheap product, it doesn't have trimmers for the individual crystals, so what frequencies on it may have an overall adjustment, or it may not. We'll find out. So we'll set the power supply for 9. What is it? 9. Oh, it's 12 volts, isn't it? That's it. That's the power supply set for 12 volts. It's not often you see those in reasonable condition. There's been some comments on the fiberglass brush, or a fiberglass pencil, or glass fiber, and we get these from RS, but you'll find online sellers with them. Some people call it a scratch brush or a scratch pencil. It's the way to get rid of bits of corrosion. There's just that little bit on 2 of the cells, where 2 of the cells have been. I don't think we've got to pop another, and these are so readily available, you know. We've got them in stock, 8s and 10s, so you know, if any of you are ever stuck, we've 8s and 10s in stock. Right, we better connect it up. Oh, we're down to this situation with loading coils, aren't we? So how's that done? It's always a pain with things with no antenna socket. So let's have a look at the squirkit. Yes, we've got that loading coil all right. So, to be honest, we need to take the loading coil out to be reasonably accurate. It's such a pain. Can't even see it. So it's L1. Out of interest, is this test point 4, which is before the loading coil. Now that's not shown on the circuit. Oh, it is. Yeah. So you go on test point 4. Okay, so it looks like you leave it in place and you go on test point 4. I don't see how that helps the SWR if you've still got the rod antenna collapsed in the set. But anyway, there you go. That's what you're intended to do. And test point 4 is just there. Just zoom in on that. So there's a loop of wire just there, and that's your test point. And then the antenna goes on to that test point. You know what? If we unsoldered that, I think we'd get a better result. Says FM antenna or rod antenna or 4 antenna, so that's just, we can pop the soldering off that. So I say I photographed that one in '84. I've never serviced one, so this is the beginner's first time. There we go. But at least it's a screened wire, so it's another plus point for Midland. Tucko coils, so proper quality. And I say there's no microchips in this, just 20 something transistors. When we come to do receive, we're going to have to take this board out to get to the back of the speaker. Not fun. The plastic, is this plastic? No, I think it's die-cast metal. That's plastic. Yeah, I think you've got a die-cast metal outer frame, and then you've got a plastic insert in the middle. That all helps with that ground plane. So I think this is going to work very well. We may even get a scratchy corner on this. I mean, we've had 6 miles on those realistic 1002s, and they're 1.5 watts, so there's every chance that a well-made, well-designed set should do that. So we'll connect it up, probably. Well, there's a good start. So with our crocodile clip BNC lead, we'll connect that to our test point there, and our earth point there, and then we'll put into the signal generator. Just widen that shot out of it, about there. Channel 14, we'll do it on 2773125. That's so bad. It can't be right. We're at 100 microvolts there. Have I misunderstood the channel chart? 2773125, and that is what we've got. So let's look at the circuit. The transmit crystals are here, so we can alter the frequency with variable capacitor 46. That must be somewhere nearby, surely. It's there. In fact, you can see it better than I can. Look at that, 73125. Oh, you're not looking at that, so I've got the wrong camera on. There you are, 2773125, spot on. I'm not bothered what the other channels are doing, but out of interest, channel 19 7815 is a bit high, but within spec. And channel 40 should be 99125, 99138, so it's actually very good. Channel 19's the worst, but it's still so within spec. What have I done to my knuckle there? Must have been, I was going to say I must have bashed it on some organ somewhere, but I'll be careful how I say things like that. We're tuning organs tomorrow afternoon. Horbling in Lincolnshire want their organ tuning. It's a bit too hot to tune organs, and so it'll be out of tune as soon as the weather changes. So we'll see. Do as I'm told though. We may not get any CBs in tomorrow. So what we were looking at was the transmitter lineup. So we've done the crystal. We'll move along the line. It's going to be L14, 14, 13, 12, 11, 10. L8, L9 is fixed, L8, L7. So starting at 14. Quite a lot. So 14, 13, 12, 11, 10. There's the 9 that's fixed. Eight and 7. 8 and 7. So 1, 2, 13, 14, 14, 13, 12, 11, 10, 9, 8, 7. Here goes. So 1.3 watts. Hang on a minute. Where are we now? Yeah, 1.3 watts. That's warmed it up. .3 watts. .5 watts. I think that's where we are. So it's a good 1.5 watts. So what's that coil? Of course, I've got the wrong camera on the inset. So key it up again, and we were there, which is 1.5. There's 2. Now at 12.2 volts on the power supply, I think it's safe to take it up to 12.8, but no further. So that extra coil, which we're trying to find out what it does, is L1. I think that's the loading coil. That's why it looks like a transmit one. So we'll deal with that when the radio's back together. Now we may have a little bit of loss in this lead, but not that much. So just going to put the power supply up to, as a temporary thing, to whilst we're keying up, to 12.8. So there's our 1.5 watts. Yeah, it's 2 watts at 12.8 volts. So I've dropped it to 12.4 volts. So, you know, with some fresh batteries in there, it's going to, and we're talking about alkaline batteries here, because if we put in rechargeables, the voltage is going to drop, isn't it? 1, 2, 3, 4.8 times 2 is 9.6. Is it? 4.8, is it? Yeah, it would be 9.6. 2, 1, 2, 3, 4, 5, 6, 7, 8. 8.4. 9 point. So if we drop the power supply to 9.6 volts, this is what you'll get if you put rechargeables in, and the answer is 650 milliwatts. So we give you the external power option on this radio. We're back to 12.4 volts. It's 1.7 watts. So it does do 2 watts, and it does it to 12.8 volts. And we'll stick it there. So that's the transmit RF power covered, and it does what it says it does just. And this is the same setup where, you know, we didn't see very much coming out of the 500 milliwatt DNT, but we had a lot of long leads for it to get lost in, and we've got one there. But the test point's a good idea. So let's look at deviation. We'll have to retune the meter. Wallow, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. Wallow. I think we're there. Now, does this have a microphone, or does it use the speaker twice? Yeah, it uses the speaker twice. That's pretty crummy. Okay. I don't think anybody'd do that these days because the cost of electret microphones is so tiny. It would be cheaper than having to change the impedance. So the only control in this is going to have to be deviation, VR3. I can't see any others. And there it is. So the speaker goes through here, through the speech processing amplification, VR3, disappears off to the transmitter and finds its way somewhere to the varicap diode, which there must be somewhere, but I can't see it. Never mind. So with my trimmer tool poised, I'll tell you what, we'll use the little oscillator. So it's quite capable of, it was 0.7 deviation. Wallow. It's now correct. Wow. You know, that must have been so lousy. I don't know how long they're given at the factory to align these things, but it makes you think it's 20 seconds. So that's the transmit. We've put it on frequency with the trimmer capacitor down there. We've gone through the transmit lineup, and now we're going to do the receiver. It doesn't give us much left, does it? Because I can only see 2 coils. There's no detector as such. It must be some double diode detector, which it is. There's our 2 detector diodes. It just relies on the filtering. Then we have a push-pull output pair, driver and push-pull, complementary pair, NPN, PNP. Very old-fashioned way to do it, because normally you'd have a chip to do the place of those, well, all those transistors. Yeah, so that's it. All you've got is L2, L3, and then lots of amplification through the filters, double diode detector, no adjustable coil. So it's those two. How do we get our test equipment onto the speaker? Not easy. I wish it'd been a test point. Now there is a test point at test point 3, but it won't be sufficient to drive our test gear. Now if we had our little amplifier here and we had an output on our little amplifier, this is something I think we need to modify our little bench amplifier which I built some time ago. We could connect this up to the test point through our little amplifier and then into our test gear, but I don't think we're going to be able to drive anything from test point 3. But we'll look for test point 3, and then you can't say I haven't been thorough. Test point 5, test point 4, which we know about. Probably staring you in the face, but it's not staring me in the face. So what transistors is it around? It's around transistor 12 and 13. So if we look in that vicinity, there's transistor 13, there's test point 3. So if we turn that round, it's actually obliterated by the potentiometer. Okay, what else can we do? You can see the taking the board out of the case looming up. If we got our amplifier and we had an output on it instead of just a speaker, we could, if we could get to the volume control and connect onto there. So if capacitor 43 has got long legs, we can get onto there. There's capacitor 43. So it's that one there. No, we wouldn't be that lucky, would we? So we're going to have to pop this board out. So I'm going to cut the power so I don't inadvertently do anything. But if we were servicing these regularly, all we'd have to do is to put a probe onto the volume control, amplify it, and run it through the test gear. But our little amplifier that I built, I never put a socket for output because I never envisaged using it for that. So it's something we need to modify. So let's guess the right screws. expect we have to pull these knobs off. Now that is obviously going to come out. I'm glad I didn't take those out, they hold something else. So I think we can get to the underside of the speaker now. So we'll connect it back up. Switch it back on. Switch the power supply back on. Get my thing there. Hopefully we can see what we're getting. So we'll get the Synad meter to there. So just to tell you, at the moment it's doing for 12 microvolts, it's doing 1.2 for 12 decibels Synad, it's doing 1.2 microvolts. Probably about where it should be. No improvement. Very slight improvement. So now we'll take that reading again. Oh, blow me, my thing's fallen off. So 12 decibels. About one, actually it's about 1.5 microvolts, and for 10 decibels I've got about 1.2 microvolts. Anyway, that's going to work fine for what it is. It's a single conversion set, and all we have to do is to put it back together. Well, that soon fell off, didn't it? I'll turn the power off. put the pillars back. There we go. Then there was one screw. That's it. So we'll power it back up and make sure the squelch works. We may as well go back onto this point. And just look at the squelch. So we've put the squelch to full, and now we'll advance the signal generator. So 3 microvolts, 10 microvolts, 30 microvolts. Squelch is coming in on full at 10 microvolts, and now we'll check it for squelch sensitivity, parking the signal generator at 0.3 of a microvolt. So it's a threshold. Signal generator on. 0.3 of a microvolt coming in at. A bit chattery at 0.7 of a microvolt. So that should work alright. So we've got the transmit light. Would have, we've got a negative clip still. Good, that's it. So we'll just solder this back together. We'll turn picture in picture off. Just going to unsolder there. It's a bit messy. Tell you what, their iron wasn't hot enough at the factory to do this. No, we're going to better do that later. We better do this first. There we go, that's the rod antenna connected. So we better get our field strength meter again. It's been getting a bit of a hammering recently. Now where did I put it? Aha. So put any old crocodile crib lead. Extend the aerial fully. Right over the bench, and try and move the camera accordingly. Melt the wax in there. I better power it back up. Just like that. You can see we've got a, oh, you can't see, we have a field strength showing. I need to just prop that up a bit. Let's put those cutters underneath. And at the same time, just that coil, which is now hardened up again. To use a ceramic tool. It was absolutely spot on. See, if I turn that, we're going down. That's definitely the peak. So it was absolutely correct. So that's good. Now we can't do an on-the-air test, we can only do a field test because there's no antenna socket. Unpower it. And remember where we put the case. Then we've got the two countersunk screws which goes into those pillars. So I think we're going to get a half decent range on this, and I'll eat Mr. Chippy's hat if we don't get scratchy corner on it or Wilsford level crossing. There we are. I better put that knob back. So this is the deluxe one. I don't know what the standard one was. We've got a bit of a power lead we'll make up for doing that. We could have made up, but we haven't done, so we'll put some batteries in it for Mr. Chippy. So there you have it, the Midland 75 720 UK, made in Taiwan, from 1981, which was another $49.99. And considering it's the same price as the DNT, I know which I would rather have, but then we haven't tested it yet. Now I have tested one of these in the past, and I seem to recall that on a good terrain test we got 6 miles just. Now the test we're conducting at the moment on difficult terrain, so it's not comparable. Oh yeah, I know what I was going to tell you in the instruction book. It tells you the truth. It tells you the real power output, which is 2 watts. And it tells you what range to expect. It tells you when using a regulated battery charger through the socket. It is a regulated battery charger, not the radio with electronics. When using a 12 volt external supply, remove the batteries. It tells you that. It doesn't tell. I don't know. It tells you that on the Alba instruction book, and it also tells you expect 1 to 1.5 miles. There it is. Expect 1 to 1.5 miles, depending upon terrain, obstacles, climatic conditions, and where the other transceiver is in use. Now I know we're going to get 1.5 miles to our first test point, and I'm hoping we get a little bit more. So thank you for watching the Midland 75 7, I've forgotten already, 20 UK from 1981.